Hi Math 2 Enhanced. This is page 12 of our packet. And today we're going to start discussing how we break down and find roots of polynomials that don't factor. And we're going to use these synthetic division skills that we've been working on to help us break these down. So first of all, notice our p of x in example 1. This one does not factor. You could try underlining the first two and underlining the last two, but you'll find that there is no GCFs. I can't do anything with factor by grouping, so it's not factorable. So I'm going to see if I can find some possible roots that I could use division to start to break this cubic third degree polynomial down into its factors. So first of all, I look at the last term, my integer, and I try to think of the things that would divide evenly into 10. And so the things that would divide evenly into 10 are things like plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So if you think about dividing 10 by negative 2, for instance, I'd get a negative 5. There's no remainder, no decimals, it divides evenly. If I took 10 divided by a positive 5, I'd get 2. No remainder, no decimals, it would divide evenly. All of those numbers that I listed would divide evenly into 10. So now let's look at the 2. So now I want to think of my factors of 2. And 1 and negative 1 will divide evenly into 2. And 2 and negative 2 will divide evenly into 2. There's nothing else that I could divide 2 by that I wouldn't get a decimal or fraction or remainder part. So in order to be a possible root to this polynomial p of x, then my root must be then my p divided by q in lowest terms, most reduced form, which we'll look at in just a moment. My possible roots, these are possible roots, would be my factors of my p divided by my factors of my 2, which are my q. And so let's take a look at what some of those numbers would look like. So right now, let me grab my highlighter. I'm going to take each one of these numbers and I'm going to divide by a positive or negative 1. So if you think about this, if I take a plus or minus 1 and I divide by plus or minus 1, my answer is obviously going to be a positive 1 or a negative 1. It depends on what I was dividing by. Same thing for 2. If I take 2, positive 2, and divide by positive 1, then I get a positive 2. If I take a negative 2 and divide by a positive 1, I'd get a negative 2. So if I take one of these plus or minus 5 factors and I divide by plus or minus 1, I still get a positive or negative 5. It depends on if I divide it by a positive or negative 1. Same thing with 10. However, now I'm going to look at taking each one of these factors of p, and instead I'm going to divide by plus or minus 2. So this is going to change up my possibilities because now my plus or minus 1, I'm going to be dividing by a positive or negative 2. That's obviously, depending on my signs, going to give me a positive or negative 1/2. Now, if I took my positive or negative 2 and I divided by this 2, I'm going to get a positive or negative 1. And I don't need to write that because I already have that. It's right here. So this is what they meant up above by p divided by q in lowest terms. So I wouldn't put another plus or minus 1 into my problem. So let me grab my eraser. And I get to erase this one because he's already there. So now my next term is my 5. So I'm going to take my positive or negative 5 and divide by my positive or negative 2, and that would give me a positive or negative 5 halves, depends on what my signs were. And now I'm going to take my positive or negative 10 and divide by my positive or negative 2, and you'll notice that that's going to be 5. It's either going to be a positive 5 or a negative 5, depending on my signs, and that's already in my list. So I don't want to put it in my list twice, so I'm going to erase that too. So these are all my possible roots. Each one of these roots gives me a possible factor. So let's list now all my possible factors. So using my red roots, my possible linear factors would be x plus or minus 1. Again, it depends on my sign. X plus or minus 2, x plus or minus 5, and x plus or minus 10. Depends on the sign of my root. Remember, it's always opposite. And then my green ones give me the possibility of having 2x plus or minus 1. That would be what the 1/2 is giving me. I also have 2x, sorry about that, 2x plus or minus 2. Now that is from the 2 divided by 2 that was equal to 1, so I didn't list it as a root. And now we're going to do our plus or minus 5 halves. So I'm going to bop my 2 up in front and get 2x plus or minus 5. And lastly, remember that plus or minus 10 over 2 that I didn't use because it's really a 5. So I also have the possibility of 2x plus or minus 10. So this one and this one, we did not list separately as roots because this is my plus or minus 1 is what it reduced to, and plus or minus 5 is what it reduced to. So now out of these possible roots that I have right here, how do we figure out which ones really work for my polynomial? Well, we test them with synthetic division. So if they work, I'll get a remainder of 0. And if it doesn't work, I'll get a remainder that is some other number. So let's see what that looks like just trying this out on 2 of them. So let's take a look at, let's try for this problem. We're going to test x equals -1. So let's set up our synthetic division. X is -1, and my coefficients of this polynomial, p of x, are 2, -1, -11, and 10. Nothing's missing, so notice I have no 0 placeholders. So I'm going to bring down my 2, and 2 times -1 is -2, and I get -3, and -3 times -1 is 3, and I get -8, and -8, and I can already see I have a remainder. Really, I could stop, but I'm going to finish this off. I'm going to get 8 with a remainder of 18. Since there's a remainder, then no, -1 is not a root. So it was a possible root. It seemed like it could have worked, but it didn't work. So let's test another one to see if it works. Let's test 1, x equals 1. So I'm going to use x equals 1 with the same coefficients, and let's give it a try. So I bring down the 2, and 2 times 1 is 2, and I get a +1, and 1 times 1 is 1, and I get a -10, and -10 times 1 is -10, and this then gives me a remainder of 0. So this works. So I happen to know that yes, x equals 1 is a root, so x minus 1 is a factor. So I can write my original polynomial, which is up above. It is 2x cubed minus x squared minus 11x plus 10. This can be broken down into my divisor, x minus 1 times my quotient. It's 1 degree less than my dividend was. So I'm going to start with an x squared. So it was 2x squared plus x minus 10. Now, I'd like to see if the 2x squared plus 1x minus 10 happens to be something that I can continue to factor. And so if it can factor, then I can use my diamond method possibly. And so 2 times negative 10 would be negative 20. And my b is 1. And I'm trying to think of two numbers that multiply to negative 20 while adding to positive 1. And I think of positive 5 and negative 4. So now I don't want to put those numbers into my parentheses because my a is 2. So my 5 and negative 4 my side numbers don't go inside my parentheses. Instead, I'm going to turn this into a factor by grouping problem. So I'm going to use some brackets here just to kind of separate this out. This is just a little work I need to do to be able to factor 2x squared plus x minus 10. So I know I keep the 2x squared and I keep the negative 10. But instead of writing x, I'm going to write my 5x and my minus 4x. And then I'm going to underline my first two and my last two. And so this x minus 1 factor is still there. And then going back to my work here, it looks like in the first one I have a factor of x. So then I get 2x plus 5, and I have a greatest common factor of negative 2. And again, I get a 2x plus 5. So now it looks like I've got my sames and leftovers. So I'm going to write this finally as an x minus 1 times my leftovers x minus 2 times my same parentheses 2x plus 5. This is my polynomial completely factored, my original polynomial completely factored. So even though originally way up here at the top, it wasn't factorable, I was able to use synthetic division to break it down into its factors. I also would know then my roots. My roots of this equation would be x equals 1. I get that from the x minus 1. X equals 2. I get that from the x equals negative 2. And x equals negative 5 halves. I get that from the 2x plus 5. These are 3 real roots for my cubic third degree polynomial. So let's take a look at example 2. So the way we're going to do rational root theorem this year is instead of you finding all the possible roots and all the possible factors and trying them with synthetic division, I will either tell you which one of them to use, or I will give you two, for instance, one that works and one that doesn't work. And you're going to just have to use synthetic division to find out which one you want to use, just like I did up above with negative 1 and 1. So when I do all my I'm going to cross that out since we're not doing that at this time. You're not going to list all these this year. I wanted you to know the rational root theorem. That's how I try to figure out some of this stuff. But for this problem, we're going to try x equals 3. So we're going to try x equals 3 and see if it's a factor of my polynomial x cubed minus x squared minus 10x plus 12. So let's test it, shall we? So my coefficients are 1, negative 1, negative 10, and 12. I'm not missing anything, so I don't need to add any zeros or anything like that. So let's bring down my first number, and let's get started. 1 times 3 is 3, and I get a 2. 2 times 3 is 6, and I get negative 4. Negative 4 times 3 is negative 12, and perfect. That 3 that I gave you did work. Well, what if it didn't work? Well, then I would have gave you two numbers, and if the first one didn't work, then for sure go try the second one. So 3 was one of my possible roots, and 3 actually was a root, and it worked. So I know that my polynomial x cubed minus x squared minus 10x plus 12 can be written as my factor. So my factor that goes with x equals positive 3 is x minus 3. And then times my quotient. And I'm going to go down a degree. This gives me 1x squared plus 2x minus 4. So I'm going to write this in over here. But unlike my last problem that I was doing, unfortunately, x squared plus 2x minus 4 doesn't factor. You could set up your diamond, but nothing multiplies to negative 4 by adding to positive 2. So if I want to solve for the roots, so first of all, this is completely factored. This is done. It's completely factored. I can't simplify it anymore. And if I want to find my roots now, just like we did on our previous homeworks, I would get x equals 3 from my x minus 3 factor. And I could either use complete the square or quadratic formula to solve my x squared plus 2x minus 4 equals 0. I know a lot of you like to use the quadratic formula, so I'll go ahead and try that here too. My a is 1, my b is 2, and my c is negative 4. And so my quadratic formula would give me negative 2 plus or minus. So then we get b squared, which is 4, minus 4 times a times c, all over 2 times 1. And let me move my screen up. So underneath my radical, I noticed here I have 4 minus 4 times 1 times negative 4. That's going to end up being a positive 16. 4 plus 16. I'm going to end up with a positive 20 underneath my radical, all over 2. Simplifying positive 20, it is helpful to think of it as 4 times 5. The square root of 4 is 2. And it would come outside my square root, and the 5 would stay underneath. So I could write this as x equals negative 2 plus or minus. The square root of 4 is 2 on the outside with the 5 left underneath. And now you'll notice that both my terms and my numerator have a factor of 2 that I can also cancel with my denominator. So I would get x equals, now careful here, negative 2 divided by 2 is negative 1, plus or minus, then the 2's cancel to 1, square root of 5. So this is this is 1 real root, and this is also 2 real roots because it's just a decimal. It's negative 1 plus the square root of 5, which is around 2.2 something, I think, and it's negative 1 minus 2.2 something. So it's just a positive and negative number on my x-axis. There's no I, so it's not a non-real. It just is a decimal that's not been completely worked out yet. So let's take a look at the next page. On this page, I have a series of problems, and for those of you watching this at home and you're not coming to class, these possible linear factors and rational roots this year we're not doing. So instead, I'm going to give you possible roots to try. So I want to do the second one with you. In the classroom, on the second one, I told you to try 2 or negative 2. So those are 2 possible roots, and we're going to see if one of them might work. So if I try my 2 first, positive 2, my coefficients, it's x cubed, x squared, x to the first, and a constant. So I'm not missing anything. So I'm going to write my 2, my negative 3, negative 18, negative 8. And then when I do my synthetic division, I bring down a 2. I get a 4 when I multiply by 2, and that gives me a 1. 1 times 2 is 2. I can already see that I am not going to get a remainder of 0. So you know what? 2 was not one of my roots that work. Let's try the negative 2. It should work. I mean, one of these two should work because that's the way I've set it up for you. So negative 2. So let's try. I've got 2, negative 3, negative 18, and negative 8. And let's get started. I'm going to bring down my 2. 2 times negative 2 is negative 4. I get negative 7. Negative 7 times negative 2 is positive 14. I get a negative 4 again. Negative, or not again, but a negative 4 times negative 2 is a positive 8, and I get 0. That's awesome. My remainder is 0, so I know that negative 2 is a root. X equals negative 2 is a root. That also tells me that x plus 2 is a factor. So I know that my 2x cubed minus 3x squared minus 18x minus 8 is breaking down into x minus 2. I'm sorry, x plus 2. X equals negative 2 gives me x plus 2 as a factor, times, now I'm going to go down a degree to x squared. So my quotient gives me 2x squared minus 7x minus 4. So I think my 2x squared minus 7x minus 4 might be factorable. I could also just use the quadratic formula if I wanted to, but I think it's factorable. And because I'm imagining my diamond, and I can kind of picture the negative 8 at the top and the negative 7 for B at the bottom. So in my mind, I'm thinking 8 and 1. I'm thinking a negative 8 and a positive 1. And I want to do this problem with you by factoring because some of us are having trouble when my A is not 1. We're having trouble factoring those problems. So let's give this a try. I'm going to do it off to the side, or no, actually I'll do it in the problem. So I have my x plus 2, and I'm just going to open a bracket because I need to do a little bit of work to figure out my other factors here. So I'm going to keep the 2x squared, I'm going to keep the negative 4, but I'm going to replace the minus 7x with minus 8x plus 1 in either order. It doesn't matter, 1x. I'm going to underline the first two and the last two. And so I get my x plus 2 is just on hold. It's just sitting out here waiting for the rest of it. And then when I do some work inside here, it looks like they have a GCF of 2x. So I get x minus 4. And then here a GCF of 1 and x minus 4. So now it looks like in completely factored form, this is x plus 2 times my x minus 4 times my 2x plus 1. So this is my polynomial, completely factored. That's my fully factored form. And if I asked you to find for me the roots, you would find that x equals negative 2, x equals 4, and then this would give me, remember we're going to take my 2x plus 1 is that equal to 0. Don't forget you subtract the 1 over, and I get x equals negative 1/2. So these are my 3 real roots for my third degree polynomial equation. And you can try the other two and check your answers, of course, in the folder. Thank you.